Well, I've spent 3 days on Alan's York JCB867, which is like a Murphy DS602 with a bit different front. And we have actually swapped the chassis because there's so much wrong with it. And the chassis, we'll just bring it onto this video. All this black is corrosion through the printed circuit board. So instead of it being green, where the solder screen is, it's gone black because it's rotted through. So there's a photo of what one should look like. No black bits, and there's one with severe corrosion. So Chippy and I don't think it's possible to repair it reliably, because whatever is causing the malfunction on receive. Anyway, we've swapped the chassis over, we've had to nick his channel selector, and he's actually getting a slightly better front. But that is what we've spent the other one of those is what we've spent. I might be 7/8 of the way there with it, but we did sort out the donor chassis. It's just getting the display to interface. Maxcom 4E seems to work, but the mic is plugged wrongly. When the plug on the mic is wired wrong, I put it on. What? Hang on, I've got the wrong mic then, haven't I? That's a porta pack mic. Right. Well, forget his mic. It's got a Baby Midland. That's what the Baby Midland that mic's for. That's the York. I've done the Uniden. We'll open this up. He's done the lids on this. He's done the power connector. It's kind of set where you should know where you are with it. It's January 82, so it's not the early one, and it isn't the late one. It's the kind of one in between one. Let's put the soldering iron on. I'll need that to disconnect the speaker, and we'll do this on our test mic. I'll just move some of this ramble. I'm going to have the other signal generator for the York. Because there was an IF problem on that board I've just shown you. Right, open it up, unsmolder the can't speak speaker. I'm trying to be funny and say smolder instead of solder, and then I can't say the word speaker. I should have said squeaker, like I do to Mr. Chippy. So he says seems to work. So we're scanning initially. Are there any duff capacitors? And I've probably said loads of times that in 40 years I think I've changed 3 capacitors on a Maxcom 4E or similar, like the Midland Precision series, which uses the same chassis. And those I think have mainly been in diagnosis rather than necessity. Don't like that transistor on that angle. It has been fiddled with. Now the meter, is it the one which has no adjustment whatever? Some do, and some have the adjustment. Sometimes it's there, sometimes that's low power. Set has low power. Good. So we'll plug our standard replacement mic in, and have we got one of these power leads on the bench? Of course we haven't. Use the crocodile clip leads. And power it up. Right, we'll start by switching to PA. Meter lamp works, which is even better. Never like the way the audio is coming through the PA speaker. It's not well thought out. So we've got CB coming over the PA speaker. Switch to PA. Testing 1 2, testing 1 2, 1 2 3 4 5, and at least you can alter the volume, which is more than you can on the Uniden 100. Right, we'll get the aero connected. By that I mean the test equipment. It's just come up to tea time. So, format of meals, being from Yorkshire, even though I'm living in Lincolnshire, is breakfast, dinner and tea. So breakfast is obviously what you have when you get up in the morning, and dinner is what you have at 12 noon, and tea is what you have between 5 and 6 o'clock. You then have a snack before bed called supper, so it's different to people in London. So, out of PA, and I've just heard the signal generator. Let's key it up and see what we get. Well, we get 4.1 watt. That might have to come down. But it might be not balanced right, so we'll see. So 4.1 watts. The current consumption is 1.135 amps. Channel 40, we've got 4 watts, and channel 1, we've got 4.5 watts, so it's not balanced. I like it to be within 0.1 where possible, and I think you're thrashing the set to get that extra 0.1 of a watt. On low power, he's doing 1.8 watts. Yeah. Oh yeah, I've tweaked up the low power. Yeah, right. Why? Deviation, for what it's worth on this test set. Wow, at 4.2. You know what? I believe it. We won't be touching the VCO. There's no sign of it being messed with, and on this you normally have to add extra components to read it. It's being cheapskate at the factory. Frequency. Now this is important. Let's go over to our signal, the frequency counter. Do you know what? It's virtually spot on. Don't want to stay put though. I don't really want it above 2.8. There we are. 2.7 toggling 2.8. Set the signal generator for that, and we're already on frequency, seeing as I've been spending the day on the other set. Let's go over to the SINAD meter, and as a special treat we'll even switch it on. So we need to plug in the test equipment. I still haven't taken the attenuated speaker back to not attenuated. Probably next Christmas when I get round to it. I've been spending time on radiograms as well. Okay. So with the SINAD meter actually connected to 12 dB, for 12 dB, what do we have? 0.88. That is okay, but I've seen better. It's supposed to be less than 1, and it is. 0.82. Ooh, 20 dB, we've got 1.5. Full squelch. Is 3 millivolts, which is too tight. And squelch threshold, in other words the sensitivity, is 0.9, which is actually okay. That's too tight. So the S meter puts 100 microvolts on, at which point it should read 9. Well, it doesn't, it reads 5. But it may be the way it's manufactured, I don't know, I doubt there's a preset. So it's 740 microvolts. And on transmit, it says 5. Right, so we'll go through transmit. This chassis is probably proved to be the most reliable. And I tell you what, the great chassis used in the Fidelity 1000 is probably the next in reliability. And the Uniden, out of the big sets, out of the big brand sets, the Unidens have been the least reliable. But then, of course, there's the Billy No Mate sets, like the Harvard Good Buddies are probably the the Shogun is the least reliable set. And yes, it's such a good performer if you can find one that works. Now, we're not going to fix those anymore because it's dry joints, and it means a massive. The last one we did, we charged a token 55 quid for 3 days' work. Right, transmit. I'm showing you the wrong meter. There we are. So we need to balance this better. So we see we've got a. I'm on low power. What a wally. Try again. So that's actually brought it up. I can actually hear this squeaking. So it's not actually. If I put that on the spectrum analyzer, there'll be a bit of rubbish. So I think they've got this as high as they can, which isn't the right way to do it. Isn't balanced. I've got 4.4 watts now. I've got to try and get a bit more yet. Where did I drop the... Sure, I heard one of the tools go on the floor, and I can't now see the tool I actually want. See if we can use that one, or whether we're going to have to pull another one from stock. Let's warm that up a bit. So 4.4, and then the power is adjusted with this final one. So when I say this is 4 watts now, remember this is a commercial test set. This is now equivalent to 7 watts on a Zetagi meter. But if you were ever inspected by the government inspectors, they're going to obviously use a commercial test set, not a hobby one. This is only reading what's on 27 megs. It's not reading the rubbish. So we've now got a current consumption of 1.096. 1.096 amps. We've lost 100 milliwatts, and it's taking less current. And it's not squeaking. It's like, yeah, it's a high pitch. And now it isn't. So, channel 40 and channel 1, let's have a look. What we've got at channel 40. Got 3.95. Probably going to be 4.05. Absolutely right, Mr. Tango. And that's as balanced as we're going to get. And well within. So, low power is now 1.7 watts, and hopefully this is the preset for that. It is. There we are, 400 milliwatts. Do deviation later. Let's do the receiver. So first of all, I need to put 100 microvolts. So it's an S9 equivalent signal, and we need to look at that on the oscilloscope. Is the detector set right? I actually think that the detector could be that little tiny bit out, just from the results of that 20 dB test. You know, I'm wrong. That's spot on. I'm not one of these garages that whistles through my teeth and go, oh, I don't know, looked at this last. That was spot on. So I tell you, it's spot on. Let's look at the SINAD meter, and let's see if we can just get a little bit better than 0.88 of a microvolt, which is already better than what the manufacturer says. But with careful alignment, I think we can do better. Remember, at the factory, they've probably got 15 seconds to do the alignment. They don't go backwards and forwards. They hit that line, and then it goes on the conveyor belt. So, yes, we've got better. The first one was out. That IF one's out. That IF smiles out. So the person who managed to get 4.1 watt out of it weren't able to get more out of the receiver, and that's where the range is. Not trying to get an extra 10 yards on transmit and thrashing the set to do so. Right, we've gone through that, and let's see what the new figure is. So for 12 dB, we've got 0.46, no 44, 0.44. And for 10 dB, .4, and for 20, yeah, 0.95. That's incredible. Let's deal with this. Oh no, while we've got this on, we'll do the meter. Oh, of course, it hasn't got a meter, has it? It hasn't got a meter preset. No. And the last thing you want to do is start modifying these so they do have meters. There's 3 versions. No meter. Well, there isn't. It's the Midlands with the 3 versions. There'll be 2 versions, and the other one with a preset on the back of the meter. And if you start modifying this version to have the one on the back of the meter, you've then lost the versions, haven't you? So it's now then not original. So what do we now have to have? We see that's come up dramatically because it was 740 microvolts, seeing as the IF was out before. It's now 270. So it's just a little bit. Reads S7 for where 9 would be. Still does plus 30. It's not exactly linear. And it's only there as a joke anyway, isn't it? So, we want to do the RF meter while we think about it. And before it was reading 5. And now it bangs across to the end stop. So the other preset down there won't shift. That's better. And now it reads 4. So remember, I keep saying this, it'll only read 4 when it's on a dummy load. When I put this on the aerial, it might read 2, it might bang across, but the radio is still doing 4 watts because that meter is relative to lots of things, including SWR. And this is probably why they put programmed fake meters on new sets, which just key up even if there isn't an output transistor. They still key up. What use is that? At least those Midland 78 still have a real meter. Even if they do take 1.5 seconds to key up. Right. Squelch. So we'll go back, now we've done all that, we'll go back to a speaker we can actually hear. And let's look at where we are with the squelch. Now again, this may be improved because of the IF being quite a lot out. So full squelch. Right, are we placing any guesses? Well, that's 100 microvolts. Let's put the attenuator on the other picture. So now it's actually 1.2 millivolts. So without adjustment, it's better, but it's not right. So what we'll do, we'll put 100 microvolts on the signal generator, and we'll adjust the squelch control until it comes in. Well, he says. So on maximum sensitivity, it doesn't do 100 microvolts. And I said there's no hard and fast rule on this, it's my experience. It does 175 microvolts. So that's far more sensitive. I like it to be able to squelch out S9, you see, but that's it. Whereas at the moment it's it's way up plus 30 way. So it's now 175 microvolts. And this will have made the threshold more sensitive. So turn that down and switch the signal generator back on. Yes. 0.3. So I'm just going to go for my T, but on the way we're going to swap this signal generator and plug into the test set behind me. I'll just return this one to the main meter and we'll just see what the deviation is. So I've got 4.2 on the Marconi test set that could be lying. Let's see what it says. Wow, it was lying. It's 6 point something. It's gone off my scale. So set transmitting on several channels at once, bit of a laugh. And people there blaming other radios for having bleed over, getting bleed over. When you've got a radio transmitting on 3 channels at once, generating bleed over, and the people, I know what they do. They've got a mate down the road with a Fidelity 1000. I'm a louder, I'm a louder, I'm a louder. Yeah, of course you're louder. But it's not, it's getting wider and wider. It's not louder, it's wider and wider. Wallow. I'm adjusting the squelch like a wally. I'll have to redo that. Where's the preset? It's that one. Wallow. Wallow. That's it. Absolute peak of 2.5. So I've got my work cut out because I've now got to reset the squelch. So having had tea, let's see what the Marconi test set thinks the deviation is. Wow, it says it's about 3.5. Well, it isn't. So it's 2.2 to 2.5 kilohertz. There we are. And didn't that turn out a nice set? Yes, Mr. Tango, it did. Let's put the squeaker back on. It's got the Maxcom branded speaker in this, rather than the Buckdo branded one. So the next thing to do is find out where his microphone is, because there's no way that baby Midland mic is going to be for this radio when he's sent to baby Midland. So pause the video. Right, we've got to the bottom of it. In the box was in fact this mic, which is a Mustang mic. So there's some people these go with the Harvard sets, which are using the 002F Cybernet chassis. That'd be like the Harvard base station, the Harvard 402 MPA, the what I just said, the Mustangs, and all those kind of sets that came out of the made in Japan Cybernet 002F factory. So some people give an arm and a leg for that being the right mic. So he's put the high quality metal plugs on, which is what we would do, rather than those 15p plastic plugs. So he says he's wired the mic and he's got it wrong. So there we are, let's see. Well, it certainly doesn't do anything the way he's got it. So let's keep that on its side. So again, we don't normally do mics, but there we go. So that radio is simply a retune in test. So let's have a look at our sheet. Maxcom. Is 9. So should have audio screen, transmit, receive. Sometimes has to be a link in. So he's got what you expect to be right. So the black one is going to, I would expect, be the audio, because it's going to be the one which the screen is wrapped around. The screen is the screen, the red's going to be transmit, the white's going to be receive. So why doesn't that work? Well, there's two reasons. One, it may not be wired up like that inside, and two, some sets have to have a link across. Right, let's open the mic up and see what's gone wrong. So let's take all the works out. Ah. This looks like it's come out of the factory, but there's no way. No, they wouldn't wire it like that. Black must be audio. So we'll put black to audio. We'll find out when we do the hum test. And if it goes, nah, I was wrong. So it's okay them anchoring that on the spare pin, in other words the receive side of the audio circuit. That is transmit, red, so we need to put the white you know what, I don't think this mic even belonged to a CB. It's the same Cybernet pattern, probably off a marine radio or something, except they're normally white. I've never seen anything wired like this, and considering the pins are are unsoldered, you know, how could that be? Anyway, what we're going to do, we'll put an extra wire in. What we got? White. We've got some white wire we have. We'll put an extra wire in rather than unanchor it. So we're going to add this centre wire, which is going to be our common. So whatever this used to work, it did not have a receive, didn't need a receive signal. And then we'll take it to where they've anchored the common, which is absolutely okay where it is. And they've done that so they're soldering to the body of the switch, so you're not getting a hand hum. But it's done such a nice job at the other end that I don't want to disturb it, and I just don't think. I think that's how it should be. Let's have a look. Wallow, 1, 2. Yep. Testing 1, 2. Testing 1, 2. Notice I dropped the solder blob in there, and it's now melted its way. Right, so now we'll plug the radio into the aerial. The one on the roof, the Antron 99 or whatever it is. Solarcon 99. And with this sensitivity, it should now work so well. I'll just pop his mic in for a moment, but we'll do all the tests on our mic, and then we'll go to the at the end of the on the air test. Let's make sure it works into our hand portable. Testing 1, 2. Testing 1, 2, 3. Fine. Good. Did he just say Maxcom 4E and was that then following rubbish ring? 19 a Roger. There we Right, there could be some speaker rubbing going on there. We'll see what it sounds like with Mr. Chippy. So there we are, Maxcom 4E, straightforward retuning test, now working really nicely, and sorted the mic out with some bizarre wiring. Thanks for watching.